So today I'm going to cover reality capture as opposed to, and how it pertains to architecture and engineering. My name's Luke. I work with DLR Group. We're an architectural engineering design firm. We're right at about 1,400 employees to date, 28 offices domestically, and I'm part of our design technology group within our firm. We've got some, offices all over the country. We're always hiring. So if any of those fit the bill for you, give us a shout. Some of the services that we provide within the verticals that we operate in, of course, architecture and engineering. But at the bottom there, we've got our new discipline, if you will, for design technology. And that's where reality capture kind of found its niche in our business. A little bit about me, that's my hero shot. My boss called me a 9-iron man. I started in our business in BIM management. I've been with DLR almost 15 years now, and through the years we've progressed from digital design and trying to get the best information into the hands of our stakeholders as quickly as possible. And about 6 years ago, we started taking a little bit of a deeper look into laser scanning, and fast forward to the Virgin Islands there, we've gotten pretty good with it. So we're going to take a deep dive into capture as it pertains to architecture, but then kind of switch our focus to BIM, because I kind of feel that of all the topics that's been covered here so far, BIM has been kind of brushed over as, okay, we go from point cloud to Revit and it's magic. And we all, we wish it was. But there's some things that we'll cover today, and let's just kind of take a dive into it. So when we're starting with BIM, like how do we get from those old dusty floor plans to this live information-filled model of assets for design? And I can't count how many times I've worn masks over my face, reading through these moldy blueprints. So, and we got 4 or 5 design iterations throughout the years. So, even when we think we interpret those correctly, it's still an interpretation. It's really not that as-built condition. And laser scanning quickly became a really good means for us to get that visual ground truth into the hands of our stakeholders pretty quickly. Shout out to Faro here. That's one of their scanners with on the HDR setting. But some things that we're using this for pre-design. So if we're talking about renovations to a specific project, it's all the way through construction, right? We're going to do construction captures, and then complete this building life cycle with post-occupancy capture, and help facilitate this large curation of data with our owners. Some of the tools of the trade. Sorry if we copyright infringed some of these photos, but we're aerial. We use aerial-based photogrammetry and LIDAR, as well as thermography. Of course, mobile scanning, that's kind of the new thing right now. We've kind of bought all in on the mobile side, and I'll explain that in a little bit. But static is still very important. I think there's I think the theme of the conference here is the right tool for the job, right? And I think we're all realizing that, and we all need to be advocates that it's not just one solution. You're going to fix a problem. There's a multitude of tools to do that. And then Revit as well. I love our mobile video capture in the lower right-hand corner. I have a little story here. I was training an intern on some of our technologies and so forth, and I was explaining, the mobile video captures for our job sites, and I could see this one guy was kind of scratching his head, and he goes, "Is that Teletubby camera?" And like literally, it's like, if you remember the Teletubbies, that just kind of stopped me in my tracks. So that's what we call it now, is the Teletubby camera. So some of the things that we can kind of cover with 3D laser scanning. And I think I've heard this mentioned a time or two already, that it was important for us to brand what we're doing different than 3D laser scanning, because reality capture is way more than points and LIDAR. Some of our projects that you can see on the screen, what architect and engineer wouldn't love the high fidelity information that we're able to get that right to their computer, right to their desktops. Essentially, you've got Google Street View for your project coming up, and then of course the high fidelity photography and LiDAR information to kind of go along with it. It's a win-win case for us. I left this slide in my deck to kind of showcase the story, right? This is a very technical conference, but at the end of the day, this data keeps traveling upstream. It eventually gets into the hands of designers. And it's important when you're in a design firm that there's always a story with the project. The interesting story with this one in particular, as you can see, it was already in the midst of a renovation. We didn't scan this to start with. That was not part of the scope that we needed to address at the time, so we opted out to not capture it. However, in the midst of construction, a tornado came through town and ripped the back half of the building off. And you can kind of see there with the additional shoring and the missing roof, so on and so forth. So this was a way for us to kind of get out there and visually explain to the community who really couldn't get into that location, to showcase the damage, to help drive some fundraising. And it turned out really well for us. And I always leave this slide into just to highlight static scanning, and one of the reasons that we chose as a design firm to move towards mobile scanning. Each one of those dots is about 3.5 minutes of my life. It's gone, right? And then calculate all that time for post-processing and assembly of the data sets. To where, in our mobile environment now, we could capture that in an afternoon. And I think it's important to kind of highlight the reason why we tend to lean a little bit more mobile than static. In a design world, we're after design intent. We're not after as-built accuracy necessarily. In some cases there are, and we're assured to address those. But more often than not, if any, hands raised, how many Revit users are in the house? Okay, there's a couple of you. So for the folks who aren't familiar with Revit, to operate in that environment, it's a very strict set of rules that you have to kind of abide by. If you wish to dimension against two planar surfaces, they must be rectilinear with each other. Anything sloped or skewed out of plane, it doesn't work. It's an unfortunate hiccup that we kind of have to deal with in our business. So in this particular project, I was able to use a lot of modeled automating tools. Most of them were from the Faro ecosphere. It worked great. I was very proud of this model when we were done with it. But when we unloaded the point cloud, it looked like a third grader drew the drawings because the building was so old and things were out of plane and askew. And essentially it was a great moment in time and a pivotal shift in how I was thinking, because at that point we realized we couldn't use that model. It was great to have, but it was not able to function in the design world. So if we're going to introduce error into the equation at some point, meaning we're going to accept that a wall is 90 degrees when in reality maybe it's 89, if we're going to accept that error on the back end, why not try to gain a little bit of momentum on the front end and speed up our capture? So that's generally, in a synopsis, kind of why we've chosen to migrate towards mobile when it's applicable. Our mobile video capture, there's a multitude of technologies that are all very similar. Any of them will work in any situation, but I wanted to highlight here, if you put yourself in the mind of an owner, What owner wouldn't love to have the ability to go back in time and look behind their walls to see where conduits are, or if there's a leak in the roof, they can actually go back and see, okay, maybe it's not the roof leaking, maybe it's a sprinkler pipe or a plumbing fixture going through that area. So it's when we start talking about that digital twin, that's really still not, it's not really cooked. What is that digital twin? This is a great example of, a data set that we can hand over to ownership, and they will tend to rely on this more often than not than the construction drawings that come along with their building. It's a 3D world now, right? And our aerial mapping and photography. On the left side of the screen, we're starting to do a lot of, construction site flyovers. And the image that you see out there on the left is going to be a little bit more of a, progress tracking. We do a lot of K-12 educational facilities. We're one of the largest architectural firms in the country that handle that market sector. And these are great little snippets that we can hand over to the public to show them, here's where your public money is going to. Here's your progress on the building. And we can kind of track it from our side too. And again, as a design firm, we want to showcase our built environment. This is what we're here to do. So we actually use our drone photography as that. We go out and do the marketing hype videos. We want to showcase to internally and externally, that the space is functioning as it's intended. As you can see, here's a football game. This is the story, right? It's not just parts and bolts and concrete here. This is, people functioning in the built environment. So now we get to dive into the fun stuff. And I rewrote quite a bit of this slide deck last night to kind of highlight a lot of this upstream workflows. I think the service providers and the technologists in this realm tend to think of it downstream, but this is looking from the design aspect. Anyone have any idea what one of the first things that comes to mind when you're talking about BIM modeling? No, spreadsheets, come on, right? This is critical, okay? If we're talking about how do we translate high fidelity design LIDAR information into a 3D environment, there's a translation that occurs. That means that parts may not match. A may be like A with an asterisk, right? So having documentation in place that allows us to kind of guide and help the owner understand what our deliverables are going to be. Everybody here familiar with the LOD and what that means? Level of development? It's not level of detail, I promise. Level of development is how far along you take a model. You can see in the upper middle portion, there's LOD 100, that elements may be graphically represented in the model with a symbol. Here's just a check that's saying that there's a column here. And then how far do you take that? Okay, then 200, you kind of get into the approximate quantities or the sizes and shapes. When you get to 300, you start putting in materials, thicknesses of the item that you're modeling. For doors, you start talking about, is it a wooden frame or a hollow metal frame door with a 2-inch head or 4-inch head? And then 400, you start getting into a little bit more manufacturer's content. You could even take it further to put the hinges on the things. So this progressively gets larger. It goes from 100 to 500. So within this document, we've got a uniformat classification noted, which essentially is every construction item known in our built environment has a code assigned to it. Is it a door? Is it a double door? Is it an overhead door? Each one of these has its own individual code. So we can go through this document and say, okay, for this particular item, we're going to model it to this level of detail, and it's going to be based upon X. You can see there on the right, we're talking about, okay, it's going to be based on the existing drawings. Even though we do have a LIDAR scan, it only measures surfaces. I can't tell you how thick, the concrete pad that we're sitting on is. So we're going to have some sort of information to back that up. And then where it's applicable, we'll include the 3D laser scan and then supplement that information with existing drawings. Okay, so we failed the first test about spreadsheets. What's the second thing that comes to mind when we're talking about BIM modeling? Oh, wait a minute. Let's come back. I want to put a pin in that. The standards has also been talked about here. And there was a few comments made and conversations that I've had that is this industry ready to standardize? It has to. If we want wide adaptation in our business, things have to being standardized. The LOD, standardization, came from a bunch of guys on an internet forum. It was called the BIM forum. It was more than that, I'm generalizing. But they came up with a set of standards, and the AIA, the American Institute of Architects, looked at it and okay, that's what we're going with. Easy. Now they've got their foot in the door. And something I wanted to highlight here, which I don't know if anyone has ever mentioned this yet, but if you look over on the far right there, they've already developed reality capture standards. So that's kind of I think everyone needs to go and check out that document and see what's in there, because industry wanted standards and now they're going to get them. So if we want any input on any of this, I think it's worthwhile now is the time. Again, this is something driven by the AIA. We need to standardize. That way we can have our contracts in line when we're talking about specifying we need LIDAR for this information, we need photogrammetry for this information. So the second thing about BIM, contracts, right? Again, very clear with our deliverables, right? So we break it down into, okay, our 3D scan is going to be this much. We talk about level of development with modeling. We could go to level A, level B, level C, and then helping the client kind of curate that data downstream. So these are all things that we're going to address up front even before we start. Some of the tools that we use off the shelf are highlighted on the screen. All of these have their strengths and their weaknesses, and I will say mainly the evil empire of Autodesk in the upper right hand is our weakness at the moment. It's the innovation when it comes with what you would think such a large product. The amount of developers that they have on that team is probably less than are in this building at the moment. So it's crazy to think such a industry driving design tool doesn't have a lot of development behind it for addressing these new technologies. And as good as those tools were, we still needed more. And being that we're within a design firm with a pretty large design technology group, we've got some really talented data scientists, data engineers, developers that work with us. And we asked, hey, can you make us an easy button? So, and they did it. This was a CAD file that we asked, hey, is there a way you can extract Revit content? And while you're at it, can you put doors in it? And about a few days later, they sent us that. So it can be done. We just the standardization and the drive from our side of the business needs to be put on the other side of the business. Let's get this stuff moving. Some other things that we're doing, you can see there, this is some of our process of capture. This particular project was a dual building. I think one of them is 18 stories. The other adjacent building was another 9 or 10. We had one person on site, and in 5 business days with a nice lunch, we're able to capture over 1 million square feet of content. And then our team was able to crank out a very nice high LOD Revit model for the client in about 11 weeks' time. Even with the automated tools, it took us that long. And some of the content that can kind of come out of that data, because we're able to capture such high fidelity information up front, we're we're able to digest that correctly downstream. And real quick, I know I'm kind of running up on my time limit here, but you know, I think we're all tinkerers, and I kind of like showcasing some of the tools that our team has developed. This is a program, it's called Rhino. It's a computational design tool. It allows us to go through a multitude of design iterations and idiosyncrasies very quickly. For instance, this was a solar panel array that we wanted to outline on a roof, and you can kind of see the white line represents the power track that needed to run back to the main switch. And you know, the next iteration, we could actually start putting in some dimensional higher LOD level to this model. And then again, fidelizing, is that a word? That's a good word. I'm gonna write it down. Dropping into solar panels in these areas, but you can kind of see how they foul the track line. And then we were able to kind of go back through and adjust those panels to kind of meet those. There was not a person who clicked on a panel and moved it. That was all accomplished with computational design. And moving into the future, we've been waiting for this in our business for years, and it still hasn't been addressed, so we just decided to do it ourselves. So we're actually experimenting and having some extremely good results with machine learning as it comes to our data sets. Last year, we were able to scan to BIM over 20 million square feet of data with our design team. We got a lot of data with scans that match BIM. So we've got a lot of information that we can start training these computers to start recognizing objects, right? First step in that is that segmentation of the point cloud and classifying it. You know, that's a wall, that's a floor, here's a desk. These are some of our initial stabs at it. And I got sort of approved to kind of show this next one, so we're gonna roll with it anyways. This is our latest iteration. Essentially, with a few clicks of a mouse, we were able to train the computer to take that point cloud, classify it as objects, and then translate that directly into Revit. That's a LOD 100 Revit model. So that was zero input from a design user. So these are the things that, as a design firm, we were hoping industry would kind of react to and help us along with. But we're here now, so what we're asking of industry is to, allow us to help partner. We've got data, we've got some really intelligent individuals with us. So we really want to get to that easy button. Everyone wants to get to that easy button. And I hope that next year we'll have a whole lot more to talk about on this particular subject.